So question R provides us that a plane pi has the vector equation r is equal to the quantity of negative 2i plus 3j minus 2k plus lambda times the quantity of 2i plus 3j plus 2k plus mu times the quantity of 6i minus 3j plus 2k. And step A, or part A of this problem, is to show that the Cartesian equation of the plane pi is 3x plus 2y minus 6z equals 12, which, as you can see right here, is what we got, but there are 2 steps to get there. Also, just a note, this x is supposed to be a z. It was just written on the board improperly. So the first step is to find the cross product of the 2 vectors in the plane equation, which is denoted by the lambda and the mu. To find the cross product, you use an equation that's on your equation sheet, and it's also available in our PSA video, but you represent the normal vector as n with the vector line over top. Then you end up getting 12, 8, and negative 24 as your values for the cross product of the 2 vectors, and this is the vector. The next step is to use that normal vector, which is 12, 8, and 24, and the point, which is negative 2, 3, negative 2. And this is how you're going to find the Cartesian equation of the plane pi. So, for example, you have to use the equation of a times the quantity of x minus x naught plus b times the quantity of y minus y naught and plus c times the quantity of z minus z naught, and that will be equal to d. However, to begin, you don't have a d, you just set this equal to 0. So a is 12, and the x naught is represented by the x coordinate in your given point, which is negative 2. So then it's 12 times x plus 2, which gets you 12x plus 24. Next you have b, which is a, and a times the quantity of y minus 3, which gets you ay minus 24. So then your 24s are going to cancel out here. Next you have c, negative 24, and you're going to multiply that by the quantity of z minus 2, which gets you negative 24z plus 48. Then you're going to move the 48 over to the right side of the equation by subtracting it, and this is going to give you the d value. So then we have, since the 24's cancel out, we have 12x plus 8y minus 24z is equal to 48. And this simplifies further into 3x plus 2y minus 6z, again this is supposed to be a z, is equal to 12. And that's part A of the problem. So part B of the problem is going to ask that the plane pi meets the x, y, and z axes at A, B, and C respectively. So A where it meets the x, B where it meets the y, and C where it meets the z. Then it asks to find the coordinates of A, B, and C. This is actually a fairly simple problem. All you have to do is substitute 0 in for the 2 coordinates at a time to find A, B, and C. So as you'll see here, A, you're going to find the x value, obviously, so you want to put 0 in for y and z. And that's going to give you 3x plus 2 times 0, 0, minus 6 times 0, 0 equals 12. 3x plus 12, x equals 4, and then your coordinate is 4, 0, 0. So the plane pi meets the x-axis at the coordinate 4, 0, 0. Then for B, you're just simply going to substitute it in for x and z, leaving y the variable in the equation, and that way you can solve. Then you get 0, 6, 0. Lastly, for C, since it meets the z-axis, you want to leave z as the variable and solve for that by putting 0 in as the x and y value, which gives you 0, 0, negative 2.
Step C. Step C asks us to find the volume of the pyramid OABC, O referring to the origin, and then A, B, and C are referring to those points that we found in step B. If you look back here, we used the x, y, and z intercepts to find these 4 points, and those were A, 4, 0, 0, B, 0, 6, 0, and C, 0, 0, negative 2. So we're going to look at the distance away from the origin for each of those. So A being a distance of 4, B 6, and C negative 2, or just 2 because it's a magnitude. So then our first step is going to be to find the area of the base OAB. So the relevant area equation is 1/2 base times height, shown here. And if we take 1/2, 4, and 6, which are pulled from the values A and B found in step B, then we get 1/2 times 4 times 6, which is equal to 12. Moving on to the next step, we have to find the actual volume of the pyramid, which involves taking 1/3 the base, and the base is just the area that we just found, times the height, and the height is going to be the third magnitude from step B, which is C, and that was a magnitude of 2. So we have 1/3 times 12 from the area and 2 from C, and that gives us 1/3 times 12 times 2, which is 8, and 8 is the volume of our pyramid and our answer to step C. Moving on to D, we want to find the angle between the plane and the x-axis. First, what we need to do is recognize that we can use the vector 1, 0, 0 to represent the x-axis, and then we could use the normal vector to the plane, which is 3, 2, negative 6, to work with our equation v dot w equals the magnitude of v times the magnitude of w times the cosine of theta, and we can use that to find theta. So when we substitute our values in for the dot product and the magnitude equations and solve, we get theta equals the arc cosine of 3/7. But what we need to remember here is that because we used the normal vector to the plane when we were finding theta, that theta is not actually the angle we're looking for. The angle we were looking for we can call phi, and phi is simply 90 degrees minus theta, or pi over 2 radians minus theta, because we were working with the normal vector and we want the angle between the plane and the x-axis, not the normal vector to the plane and the x-axis. So when we subtract arc cosine of 3/7, which is theta, from 90 degrees, we get phi equals 25.4 degrees, or 0.443 radians. And that angle is our answer to step D.
Question E asks us to hence or otherwise find the distance from the plane pi to the origin. Now, we see hence, so we know that we need to use the part of the problem before to answer this one. And that part will be the angle phi that we found, which is the angle between the x-axis and the plane pi. Now, in the upper left, you can see the plane pi visualized in the coordinate system, and that's just for anybody's reference. And then in the upper right, we can see a triangle that represents that angle. Now, recognize that this is not the right triangle that we want. We want rather the one that's in the lower left that has the hypotenuse on the x-axis and the longer leg on the plane pi, rather than the other way around. This is because we need the third side of the triangle D to be perpendicular to the plane pi, and we needed to intersect the origin. And since we have the right angle between the two legs, that's now been achieved. Once we have that conceptualized, we can see that the sine of phi from the previous question is 3/7, and the sine of this triangle is opposite over hypotenuse, d over 4. And once we set those two equal to each other and solve for d, we find that d equals 12/7. In the problem F, we have the task using the answers from C and E, find the area of triangle A, B, and C. Now, we do this by using the volume equation of a pyramid, like we did in problem C, in order to solve for the area. Now, the volume equation says that volume equals 1/3 times the area times the height. So, in problem C, we found that the volume itself is 8 units cubed, and now the two unsolved parts of the equation are area and height. And in problem E, we found the height, which is d equals 12/7, and that's the height of the pyramid again. And now that we have 8, 1/3, and 12/7, we can solve for area, and we find that area equals 14 units squared.